So here we are in assignment 5. We're going to look at the STP spanning tree protocol in action. We have the two connections between our two switches here, and they cause us to they create a switch loop. So in order to investigate how the switches are dealing with this, actually we will look at what interface are they actually switching off, what do they decide to do. In order to look at this, we're going to look at this network in a bit different way from this here. So I'm going to bring up a network here. It's the same, or a network diagram. It's the same network as you can see maybe. We have PC1 over here, we have PC2 over here, and the two switches are now drawn a bit different. I've done some work here. I have identified that port 1 is ENS33, Linux interface 33, which is connected to PC1. And the same over here, PC on switch 2, port 2 is connected to PC2, and so forth. I have identified what ports and interfaces are being used on the two switches. I'll show you later how to identify this. Right now, we're only concerned with the functionality, what the two switches, how they're going to deal with this loop here. So let me simplify this here. We have the networks there, and I'll bring up workstation for you. Here we go. Right now we are in switch 1, so that's down here. We can try and look at what traffic we have on port 1 here. So I'll bring up port 1, which is ENS33. I'll click that over here and start Wiresharking. And we can see here that there's not a lot going on port 1 here, 33. Only STP spanning tree protocols frames are coming out here on that interface. And they're going out here to PC1, who will not do anything with it, and it's also going to our workstation laptop, who will also not do anything with these STP frames, because they are not switches. They do not talk STP, so they will just ignore this traffic. Let's stop sharking here. Let's move over to PC1 and generate some traffic. What I'm going to do on PC1 is actually, I'm going to send pings over to PC2. Did I say PC2? I'm sending pings from PC1 to PC2. And what we want to learn here is, what are the switches doing? Are they sending the pings this way over the VMnet 6 or port 2, port 3, or are they sending the pings over port 3 and port 1? What will the switches do? That is what we want to investigate. Or are they the switches sending them on both links here? I can tell you that's not the case. What the switches will do is they will, for example, switch off port 2 on switch 1, for example. That is what they will do. So how can we check this? Let's move over to PC1 and get some traffic going here. I'm going to ping PC2, and here we go. So, and move back to, say, switch 1, and let's see what's going on here. I'm going to first check on port 1 that we actually do have the traffic going in the ping traffic. We should see the ping traffic there, and sure enough, here we have our ICMPs, and you can check the addresses there, they are correct. If we move over to, let's look at switch 1, port 2 stopped here, and I'll select port 2, which is 39, and start again. And oh, not a lot going on port 2, we only see STP traffic. So the two switches are talking STP on the VMnet 6 connection. Then I expect on port 3 to see my my ping traffic there. That was not what I wanted. I want to select port 3 on switch 1, ENS 38. Let us see what's going on there, and I do expect to see my ICMP traffic. And sure enough, so we now know that our traffic is going this way here. The two switches have switched off either this interface or this interface. We cannot know at this instance in time which interface has been switched off, but one of them. That's details. This is an old trusted protocol. It's working. So one of the interfaces are off, and our switches have disabled the switch loop. Everything is fine in this way. We see that our network traffic, our pings from PC1, originating from PC1, they go this way over the port 3, port 1, between switch 1 and switch 2. So the question is, which one of these ports up here have been switched off? In order to see that, I'm going to bring up some more details about the two switches. I'm actually going to bring up the MAC addresses of the switch port. This one. So port 2 has this MAC address here, and port 3 over on switch 2 has this MAC address. If we bring up workstation and monitor again on switch 1, we monitor port 2 on switch 1. I have that here. I'll bring up Wireshark, and I want to monitor port 2, which is ENS Linux interface ENS 39. And we see here that we have our STP, our spanning tree protocol traffic. I'll stop that, stop the capturing of packages, and look into the frame that has been sent here. If we look at the destination address, then that says, I can bring it up down here, it says 0180, oops, destination address, there we go, 0180 C2. That is a STP spanning tree protocol multicast address, which means that any device, in this case on VMnet 6, on this link here, will be looking into that package if that device speaks STP, speaks spanning tree protocol language. The source address, where's this frame coming from that we're looking at here, this frame up here? If we look at the source address, we have that here. It is 776B3C, and if you look at it over here, that's coming from here, from switch 2 port 3 on interface 39, 776B3C. So it originates from here, go out on this network part here, or network segment, and the only receiver in this case is switch 1 on port 2. So switch 1 on port 2 will look into this frame and act according to what it says in there about STP. Should we change the network, or what should be done here? So this tells us that only port, let me clear this up, only port 3 on switch 2 is active. We don't see any packages on this link here originating from port 2 on switch 1. So switch 2 has obviously by STP, in accordance between the two switches, been muted. So we have our traffic, our ping traffic from PC1, originating from PC1, going through, through port 1, over to port 3, port 1, and out on port 2, to PC2. So this is the route our traffic is traveling right now. What happens if we disable port 3, switch port 3 on switch 1? What we expect should happen is that our pings should now travel in on port 1 as before, out on port 2 over to port 3, and then out on port 2 over to PC2. So that should be the new route that the switches should set up for us. In order to monitor this, we will take a look at the traffic on port 2. We'll monitor that, and that is 39. I'm on switch 1 here, 39. I'll start capturing there and see what I have going there. Right now, I should probably only see STP traffic, spanning tree protocol traffic, and that is how it is. So if I bring down, let's check over on PC1. We are running pings, and they are going to PC2 on the .10 address. Back to switch 1. We have our STP traffic on port 2. Now let's bring down port 3, ENS38. You can see I've already worked with that here. Let me clear that for you. 38 down, and look what happens. 38 went down. If we move over briefly to PC1, it's still, it stopped. And that was what we expected. The pings are not going through at the moment. The two switches are working hard on rerouting the traffic. Let's take a look at what is happening on port 39 up here, port 2, ENS 39. Nothing so far. Oops. And did you see that? Here comes our ICMP traffic now on port 2, 39 over to port 3, 39 on switch 2. Okay, destination host unreachable. Oh, did you see that? For a short moment, destination host was unreachable, and now we have the ICMP traffic running. So the two switches have rerouted. We can check on port 3 now, on switch 1, that we have the traffic down there, that we do not have any traffic. Oh, we cannot, because we disabled the interface, so it's not part of, it's totally turned off, switched off. It's like it's not existing anymore. Wireshark will not list that as an option for monitoring. So this was a failover, which is actually not a bad thing. We had a failover. This interface here was invalidated, disabled, and so this link here went down, so to speak, and now our two switches are sending the traffic over the port 2, port 3 link up here. So in this way, actually, by having redundant connections between two switches, if one of the cables are cut or for some reason something goes wrong with that cabling, the switches will automatically switch to another cable, so to speak. And in this way, you will not have a long delay. You will not have your network down for a long time. You will have a nice uptime for your circuit, for your network. And that can be quite handy, actually. So very nice here.